Well, hello. It's a rainy day and not much to do but make a video. And this is the first video of the season at the camp. I got a water heater that was given to me. You've seen it maybe in some of the other videos. That is for the laundry. It's out in the garage. I'm up in the attic of the garage right now. And it was a cheap water heater with a 6-year guarantee on it. It didn't have a replaceable anode rod. At least I didn't see. So maybe they welded in a little one at the factory. You know, being cheap, they didn't want to put a port in. But anyways, there was no place to put a replacement anode rod in there. And the bungs at the top for feeding water in and out, those are both male. And even with a female to female adapter, I couldn't get this down through the pipe with this insulator there. So I took out the TP sensor on the side. You know, it fit in there, and you know, it's kind of nice because it's centralized in the tank. So I started my test, and I started the laundry after I filled up the tank again. And I got to the point where it was about 10 minutes away from finishing, and I walked away to do something for 10 minutes. And I came back, and there was water shooting all over the place. So it turns out that don't buy the cheapest one you can find. This is what happens. This is the insulator tube. The top section is sort of epoxied in there. But the issue is the inside of this well is perfectly smooth and polished. As you can see, I popped it right out of there, and there's no roughness. There's no residue from any of that potting. This thing just popped right out. Now, my water pressure is a little high at 65 pounds. But in the house, I reduced it down to 20 pounds to make sure I don't have any leaks, because a lot of my pipes freeze in the winter. And so you come back, you never know what's going to be leaking or what's near leaking. So I like to run low pressure. But out at the garage, because we do you know, yard spraying and everything else, I need to get some distance. I run the full pressure, and that's what the laundry works on. So anyway, let me just stop this a second. You know, I can still do the pressure. I got this little jug here. I've had this thing running for about 3.5 days now. And as you can see, the water's turned a little rusty. I got a trowel that was really rusty. I polished it up a little bit, had some cement on it and everything, and there were some places that I got down to bare metal, other places I didn't. So let's just stop this for a second. So I got the anode back in my simulated water heater. Like I say, this trowel is partially rusty. I ground this down to some bare metal to simulate the test. So as you can see, it's 1.6 volts that I got from the electrode, and running at about 1.1 milliamps. So this doesn't take a lot. It comes with a wall wart that says 25 volts, but it puts out like about 40 volts. It's purely transformer. It's not electronic, and it has a little LED on it, and I guess the LED is part of a current sense. Once you get about 1 milliamp through, the LED lights up to show that it's actually connected. And in my big tank, it was about 1.7 volts differential. Now this electrode here, this is positive. I thought it would be negative, you know, it just was in my mind, but it's actually positive. Like I say, I've been running it for days. This trowel, there's the negative. So if you have a water heater and you have an electrode and it's leaking, like I have all my DC water heaters are a pulse DC, and it's positive with respect to ground or what the tank would be. So a little positive leakage is not going to eat up your tank. It's actually going to protect it. So as you can see, this is climbing up because I had cleaned off the electrode. This thing takes a little time to settle up. But let's remove this so you can see current goes down to 0, goes up to 12.8 volts. Now as you can see, this is the shiny metal that I ground down, and the rest of this is kind of rusted, but it's been losing some of that rust coating. So yeah, there's some areas over here that along the edge, you can see that. So this has been sitting in water for 4 days almost, and there's no sign of rust on it, so it's getting protected. So it does work. So what you got to figure out is some way to get about 1 milliamp in, and because we're a camp and everything's mostly DC, I don't want to run an inverter just to power this thing up. And that wall wart is just another vampire taking power. I'm running this right off 12 volts, as you can see. And once I hook up the other contact, you can see the voltage drops down to about 1.5. It'll start building up. And I got the 1 milliamp. So essentially what they were doing is they were operating off 40 volts with a really big resistor. And what that meant is if the voltage changed slightly or tank conditions changed slightly, it would just sort of self-adjust. It's, because your numbers are so big, 40 volts going in and you're going down to under 2 volts, little variances in voltage don't matter. So all I really have is this is two 5.1K resistors from a 12 volt supply, and that 1 milliamp of current dropping the voltage down, and that's all you need to run this. So I'm going to be doing some more tests. I got a piece of copper to put in, so I'll stick the copper in at another time and measure the voltage from copper to steel and see what that is. And so if it's like 1 volt, you got to supply minus 1 volt to reverse that process. But this seems to work, other than it leaks like hell. So that's today's video. So my advice to you is, don't spend under $60 on a anode rod, because it just might pop out.